So in exercise 11C and 11D, we were looking mostly at exponentials. And remember that logarithms are the inverse of exponentials. So we now want to look at the logarithmic function. And it says they're mostly with base e, although we will have a couple of questions that have base 10 there as well. So our natural logarithm, that word natural, refers to a logarithm that has a base of e. The logarithmic function with base e, we can write it out the long way as log base e of x, but we all like shortcuts, so we can also write that as ln of x. And as soon as you see that, you know that that means a base e. On our calculator, the one that says the word log means a base 10. The one that says ln obviously means a base e. There is also a little reminder here of all the log laws. We covered these in one of our previous topics. Remember that if you have the first law here, if you have a power of n, the log law says that you can bring that power of n down to the front of your logarithm. Remember that rule? The second law that's there, log base e of e to the x, if it's a base e and then you have an e to the power of x, the base of the logarithm and the base e that you're finding the logarithm of, they cancel each other out and you just get the x. You can prove that by doing a sliding base, which I'll probably show in one of the examples in a minute. It also works for e to the power of log base e of x. The base e and the log base e cancel each other out and you just get the x. If you have log of two things multiplied, you can separate that to be log of x plus log of y. You separate that into two logs that are added. And then the next one is for the divide. If you have log of x divided by y, you can separate that into two logs that are subtracted. So log base a of x, the top number, minus log base a of y, the bottom number. Okay, so all that stuff we've really talked about before, so it's a nice little revision. Question 1, use your calculator to find the following to 4 significant figures. And I'm sure you probably remember how to do this as well. So grab your calculator. The first one says log base 10, which means that you use the one that says log. You don't have to type the 10, remember, that's done for you. And you just type in 2.556 and press equals. 4 significant figures means I want the 4075. Because there's a 6 after that 5, I need to round that up to be 0.4076. Okay, that's all on the calculator. Part B, log base e means that I now want to use the ln button on my calculator. Log base e is ln, and then just type the number 2.556. So it's the same number as the first one, but we're just doing the different bases. The first one was log base 10, this is a log base e. So that is 0.9384 to 4 significant figures. Yep, everyone's okay with this? Great. All right, C, still just calculator stuff. It's a log base e, so ln, the bracket is already there for you. You just have to press your fraction button. 2/5, press equals. Okay, it is okay to get a negative number. 4 significant figures is minus 0.9163. Part D, we could do this, okay, without the calculator. What's the answer going to be? 5, okay, because that was one of our rules. The log base e and the e will cancel out, but just because this said to use the calculator, let's show that it does work on our calculator as well. So log base e, and then I press shift ln to bring up the e to the power of 5 equals, and there it is, the 5 that we knew we had to get. All right, question 2. Find log base e of e to the power of 8. So yeah, we can use our laws in here for these ones because it doesn't say to practice with our calculator here. So the log base e and the e are going to cancel out, and that is going to be equal to 8. Part B, it doesn't just work if it's a base e as long as the bases are the same. So log base 3 of 3 to the power, those 3's are going to cancel out, and it's just going to be 2.5. Okay? E to the power of log base e of 8.1. Again, we have some cancelling here, right? The base e and the log base e cancels out, and the answer is 8.1. I thought I'd just take a chance here, even though we can obviously get the answer that quickly, just to demonstrate for this one, if you forget that rule, because sometimes I look at that one and I go, oh, I just had a little doubt for a second. Let's just practice with the sliding base to show why that works. So if I wanted to show that, I'm going to call it y equals e to the power of log base e of 8.1. And doing a sliding base, I would keep the base e, so it's log base e of y equals log base e of 8.1. Because they are both log base e's, those things at the end there must be equal, which means that y must be equal to the 8.1. Yeah? Just kind of showing you how it works by using a sliding base as well. And D, now that we've established that it works, base e of log base e cancels out, so my answer is going to be 2a. All right, so hopefully we're pretty comfortable with that. On the next page, question 3, we want to sketch some logs. So question 3 is we want to sketch the basic log, and then in question 4 we're going to be translating it, moving it around. So what does the basic log look like? Let's draw up a Cartesian plane. X and Y. Now, usually when we're first exploring a graph, we kind of use some values to help us see, sub in some values to help us see what is happening. If you were to grab your calculator and we're doing log base e, so we're going to be using the ln button, if you select any negative number of x, so let's say, for example, -2, ln of -2, your calculator will give you an error, and you can keep trying other ones if you like, but that is telling you that the graph actually doesn't exist for negative values of x. There's nothing over there, okay? What about 0? If we go ln of 0, we still get the same thing, okay? So it doesn't exist there either. So it's going to be in the positive values where the interesting stuff is happening. Let's try ln of 1. ln of 1 is equal to 0. So x value of 1 is my x-intercept. If I do the next value there as well, ln of 2, unfortunately it's not a nice whole number, but it is a value. It's 0.7 approximately. So I'm going to put that on here, there. I'm going to label that point as 2, and I'm not going to put the decimal number in. I'm going to keep it as an exact form, which is ln of 2 that I put in my calculator. Now, obviously that's only 2 points. We don't want to be subbing in points here forever. What do you think is going to happen? What is happening with that 0? We had an error there at 0 when we put that in. Yeah? It is a vertical asymptote. So 0 is a key point, so we want to draw a vertical asymptote down here. VA for vertical asymptote at x equals 0. And if you want to just make sure, you could sub in a number between 0 and 1, like, for example, 0.5. Log of 0.5 makes negative 0.6. So the curve is actually coming down like that. And the closer you get to that asymptote, the more negative it's going to get. It's going to get quite steep going down that direction. But it will never touch an asymptote. As we know, curves can never touch their asymptotes. As I keep going past the 2, it is going to keep increasing, but slowly. Okay, so I want to show that it's going to continue coming up here, but it's not particularly steep. It does not flatten off though. Okay, it does keep increasing. There's no asymptote that it's approaching. It does slowly, bit by bit, keep increasing. Hey.
I just need, do you have any spare algebra booklet for year 7?
Yes. Just one?
Yes, please. Thank you so much.
Okay, so that is your basic logarithm, and as we always say when you're drawing a graph, you want to show the asymptote, you want to show the intercept, and you want to show one other point. That's your basic rule of thumb to go by, okay? So question 4, we're now going to move this logarithm around. Here's question 4a, log base e of minus x. What does putting a minus in front of that x do? Does anyone want to have a guess?
On the x-axis.
Exactly, perfect.
Vertical axis.
The y-axis was right. Okay? So replacing the x with a negative x, we did this at the beginning of the year. Replacing an x with a negative x reflects the whole graph across that y-axis. So has my vertical asymptote moved? No, it has not. So let's draw that in there. Vertical asymptote is still at x equals 0. The intercept before was at x equals 1, so when I reflect it across, it's going to be at -1 for my intercept. And at -2, that's going to be the ln of 2. So my extra dot here, that value would be -2 ln of 2. You can always sub those into your calculator. So you could get your calculator out. Actually, let me just draw the graph in there first before I do that. So there is my logarithm reflected across the y-axis. But as I was saying, you always get your calculator out and go, all right, I'm doing log of, and I want to put -1 into that equation, and you get your 0. So you can still do it by subbing in values. Okay, we don't need to do any domains and ranges, so let's move on to B. B, we are doing log base e of x minus 3. What does that x minus 3 in the brackets do? Moves it how many places? 3 places to the right. Okay, because it's a -3, it moves it to the plus side. So that is moving our vertical asymptote. So instead of it being at 0, we now have our vertical asymptote over here at 3, and I'm going to still write on it vertical asymptote x equals 3. And although those other 2 key points have also been moved across 3 places. So my intercept was at 1, move it across 3 places, it's now at 4. And when I go to 5, that's going to be my ln of 2. So up here, 5 ln of 2. And there is my logarithm. Now you can keep that pattern. As long as you can find where that asymptote is, your intercept should always be 1 space away from it. If it's positive, it's going to be 1 space to the right. If it's a negative x, it's going to be 1 space to the left. And then your next point is always going to be ln of 2. The only time that would change, obviously, is if I'm moving the whole graph up or down or making some other unusual change like that. Part C, log base e of x plus 1. So the x plus 1 is going to move my asymptote to the left 1 spot, so to -1. So asymptote, it's at -1, so vertical asymptote x equals -1. The x has a positive coefficient, so my graph is going to be on the right of that. And 1 space away will be my x-intercept, which will be going through the origin. And 2 spaces away, which is when x is equal to 1, it's going to be at ln of 2. So it's 1 ln of 2 for that second point. I know I'm getting faster with these because it makes sense. Getting faster because it's getting easier, right? One last one, log base e of 2 minus x. Where has my asymptote moved to? The right, 2 spaces. So it's, what did you say?
I said negative equals 2 positive.
But it's whatever makes the bracket 0. What is going to make that bracket 0 when x is a positive 2? Okay, so the asymptote is at positive 2. The minus sign is on the x, which means that my graph is going to be reflected across. It's going to be going the other direction. So positive 2 for the asymptote. Vax equals 2. Because of that negative in front of the x, like I said, we're going to the left of that asymptote. 1 space away at x equals 1 will be my intercept, and 2 spaces away will be ln of 2. So it will be 0 ln of 2. And that's it. Easy enough? We're done. So 11E.